Hello, good morning, good evening, wherever you are. My name is Mark Borstein. I am the co-author of Kubernetes and Enterprise Guide 2nd Edition, along with my partner in crime, Scott Surovich. And so far in this video series, we have walked through deploying Docker from Chapter 1, set up kind and a little bit of load balancing in Chapter 2. We're skipping Chapter 3. There really aren't any labs in Chapter 3. It's mostly a reference chapter. Mostly because our publishers made us put it there. But it's actually a really great chapter. I actually go to it before I even go to the Kubernetes documentation, to be honest. Scott did an amazing job putting that together. And then, so now we're in chapter 4, where we're going to get into services and load balancing. Now, I know when I first started with Kubernetes, this was a big mental block for me. I had a really hard time wrapping my head around all the different layers of networking, and Scott likes to call it the Russian doll set of networking in Kubernetes. And so Scott does a great job of breaking down networking in Kubernetes so that you can use it. It gives you enough detail to understand what's going on while not bogging you down in too much detail. And then, we do have an enterprise spin. And so we cover a couple of really important topics in here. The first being where we're going to start with, how you deploy an Ingress and what that means. Getting into load balancing by deploying MetalLB, a very popular load balancer, especially with on-prem solutions. And then finally, at least for this video, we'll get into external DNS management. So how do you publish DNS records outside of your cluster when new services get onboarded? The final lab in the chapter is around a great project called Global Load Balancer. That probably deserves its own video, so we're probably going to hold off on that until next week, and we'll break this chapter up into a couple of videos. As we get deeper into the book and we get into more advanced topics, we will probably spend more time on individual labs than chapters, so it won't be unusual for chapters to be broken up into multiple videos. There's a lot going on in each of these chapters. So that said, dive in and have some fun. So I'm going to start here on page 122, and that's where we start talking about deploying Ingress controllers. So I'm not going to go through all of what is said in the rest of the chapter. It's a great chapter. It's got a lot of great diagrams. One of the really tricky things with networking in Kubernetes is it's so layered that you really need a visual look at how that comes together. And you'll especially see this in a lot of Ingress controllers, especially the commercial ones, actually have GUIs to visualize it. Later in the book, when we start talking about Istio, the Kiali dashboard really becomes a big help trying to get this stuff visualized and seeing how the pieces fit. So we're starting off, you can see here on my screen, I've already got a cluster running. The easiest way to get that cluster running was I started with an empty VM that had Docker already installed, run create cluster.sh, and just stand back, come back in a few minutes, and you'll have a fully running cluster, including Nginx for Ingress. So now that we got that up and running, the first thing we're going to do is go ahead and just launch an image. So we're going to just launch another Nginx image. So nothing crazy here, creating a deployment, Nginx Web. Real quick tip, anybody who is using us as a study guide for any of the Kubernetes exams, CKA, CKAD, which reminds me I gotta get that renewed, or CKS or the new associates guide, learn to use the shortcuts. Trying to remember the YAML or whatnot, learn to use these shortcuts in kube control for creating deployments, pods, whatnot. It'll save you a ton of time. So let's go ahead and create our deployment in our pod. And let's take a look at what's going on. I think I put it in default. Okay, cool. So we now have an Nginx pod running. And if we take a look, we will have so we have the deployment, but as that deployment's running, you now need a way to talk to that deployment. You need a way to reference that deployment. Now you could do it by pod. That's kind of inefficient, especially given the fact that, this part here is random. I mean, this gets generated randomly by the deployment controller. So you're going to want to create what's called a service. Now, the easiest way to create a service for a deployment or a pod is use kubectl expose. Again, this is one of those shortcuts that it's creating what's essentially YAML. It's running API calls, but it's doing it for you without having to memorize what all the different settings are. So I'm going to go ahead and let's expose our service. Let me come back here. And that didn't work because I didn't copy the whole thing. So what we're doing here is we're going to expose the deployment we just created, port 8080 to port 8080. So every service has a port that's exposed. So if you're thinking about this as what the world sees from the outside, what port to hit, and what port you're listening on. So one thing that I'll point out here is that we're doing everything on port 8080. You can do port 80 on the outside and port 8080 on the inside, which means that your Nginx image does not actually need to either run as root or have the appropriate capability to run a privileged port. You really never need to run a privileged port in Kubernetes. If you are, then quite frankly, you should probably reevaluate the way you're designing your pod. But that said, let's go ahead and create this expose. And if we do a check on services, we now have a service running in default called Nginx Web. It's a cluster IP. So that IP address, that 10.98.243.126, that is an automatic IP assigned by Kubernetes. Actually, I don't think I can ping it from here. 10.98.243.126. Yeah, so it's hanging because it's not addressable. It's only if I exec into a pod right now. Let's see if I can find a pod. Pods, all namespaces. I'm gonna guess that Nginx has a. Let's see here, kubectl exec ti and ingress Nginx bash. Nope. Oh. I can't type. There we go. All right, so now if I want to ping this IP address, nope, that didn't work either. Oops. Can I at least do this? Okay, so that worked. So I'm able to pull that out from inside of the Nginx pod because Nginx is inside of our cluster or inside of our Ingress pod. We'll see if that'll work here. I don't think it will. See, so it's just hanging there. So you can't get there from the outside of the pod. So we have a service. Service lets other pods talk to our pod without having to know the IP address because that would get old kind of quick. So we now have a service. That service will let us reference our Nginx image from outside of our pod without having to use an IP address throughout our cluster. But now we want to expose it to the outside world. We want to be able to access it from the internet or from our network because quite frankly, this isn't really a lot of use the way it is right now. So hence, this is where the Ingress controller comes in. So when we create an ingress, we are going to go ahead and create this file. nginx ingress.yaml. And I'm just going to copy and paste this right out of the book. Except it's over 2 pages, so, and the formatting got screwed up. That's okay, we'll fix this. All right, so let's fix this formatting. So the first thing you need is a host. Now this got 192.168.2.104.nip.io. We use nip.io throughout the book. If you are running on a corporate network, it might block you. Just fair warning. The great thing about nip.io is that you send nip.io a host name with an IP address in it, and it gives you back that IP address. So it's a great service, works really well. And when you don't have the ability to manage your own DNS, or you just want something quick in a pinch, does a great job. So this is going to expose our web server that we just created in our deployment to webserver.192.168.2.104 nip.io. My VM is 192.168.2.104. So you're going to want to replace that with whatever your IP address is. So let's clean this up. So our host is HTTP, and there's going to be paths. Line that up. And so an interesting thing about Ingress objects is they're very generic. They are maddeningly generic. And so what you will find is that different Ingress controllers help you customize different ways. And ultimately, they almost all have their own CRDs. So for instance, Nginx still relies primarily on the regular Ingress object, but Istio, when we get to it, you're going to use your own, its own CRDs. Traffic is another popular one that has its own CRDs. You can use Ingress objects, but you probably end up using their CRDs once you get used to it. And quite frankly, what you're going to find is that the future releases of Ingress, when Ingress 2 comes out, it's going to look a lot like these CRDs where it's breaking up your front end with your traffic routing to give you a little bit more power in how you route traffic. So that said, let's kind of look at this object here. So we start off with the metadata. We're going to throw it in default. We give it a host. So this is going to intercept all requests with this host and go ahead and forward it on to our Nginx pod. Based on the path, you can do different paths. So let's say you have multiple services on the same host, but different paths go to different pods. You can set that up. And then this is the name of our service that we created, and this is the port number. Phooey. Let's do this then. I was probably messing around in, yeah, nginx ingress.yaml. All right. So once this is created, we should be able to access it. So let's go ahead and fire up good old Firefox. And HTTP web server 1.192.168.2.104.nip.io. And winner, winner, chicken dinner, we're now routed to Nginx. And if we take a look at our lab, yep, that is the picture we should get. So this was an extremely simple use case, obviously. There's no TLS here. There's no, there's no advanced routing. Nginx is the simplest of all of the Ingress controllers. I know I love it. It's simple. It's there. It works. But if you want to get a little more power, like I said, you've got traffic, you've got Istio. I think actually Scott has a list of the various layer 7 balancers. So yeah, and if we come back here and get kube control, get ingress, and we're in default. So there we go. That's our host. That's where we went to. It's got a 172.18.03 address. So yeah. So that gives us our Nginx service. Next up, let's talk about layer 4 load balancing. So this is an example of a layer 7 load balancer using Ingress Nginx. But you're not generally going to go directly to your cluster, right? Like you're going to have something that sits above your clusters that's going to handle load balancing for a few reasons. One, we had to do a couple of tricks to get Nginx to run on port 80 that you're generally not going to want to do. You're generally going to want to have that load balancer layer on top. And so if you're running in the cloud, like you're running EKS or GKE, excuse me, if you're running in the cloud, you're running GKS or EKS or GKE or AKS, those systems have load balancers. And so what that means is that when you create a load balancer service, which is what ingresses generally are, a little bit of code is going to call the cloud services API and create a load balancer for you. So in the, depending on how you set your annotations on your service, like in the Amazon world, it might create a network-based load balancer, an application load balancer, or a classic load balancer, right? And so we're on-prem, we don't have that. So we're going to go ahead and deploy a tool called MetalLB. This is a level 4 load balancer. So I've been using the term layer 7 and now layer 4. These are all layers of the OSI model of networking. Layer 7 is at the application layer. So that means that when Nginx receives the HTTP request, it's actually parsing out the HTTP request, reconstructing it, and sending it downstream. Layer 4 load balancers don't care about the payload. They're just doing it at the networking layer. So packet in, figures out where the packet's got to go, forwards the packet there, and then it goes back to the user. And so we are going to deploy the MetalLB layer 4 load balancer. So we are going to go straight to page 125. And if I go in here, we're in chapter 4. And yes, so let's go ahead and do install MetalLB. So created the namespace, deployed a bunch of stuff, and there we go. So that was a lot. Let's kind of step through it while it's pulling stuff down. So first thing we did was we ran a kube control apply. This created all the different objects that MetalLB needs. This is the beautiful thing about Kubernetes. It's all API driven. So you've just deployed a really powerful piece of infrastructure with a couple of text files. And then we go ahead and create the config map. And at that point, it's now complete. And there are two pieces to MetalLB. There's the speaker and the controller. The speaker broadcasts what services are running on a particular node. The controller manages all that. So let's see here, kube control get namespace. So there's MetalLB system, kube control get pods, and MetalLB system. All right, so now that's all running. And so let's go ahead and I'm now page 126, and we are looking at networks. So we did this a little bit in our last, interesting, it's 2 subnets. I did not see that coming. We did this a little bit in our last chapter, in chapter 2, where we had to set up a container that ran on the same network as Kind inside of our Docker cluster. Kind runs on its own network. And so we can see that the Kind network has, this is its IP range, at least for IPv4. This is IPv6. We're just going to ignore IPv6 for now. So it's entire class B. We're not going to use all those IP addresses. So let's go ahead and take a look at the config map. All right, so here's the config map, and we're going to skip the annotations. Oh, no, this always drives me nuts with config maps. Okay, so we have an address pool in here. So this was 172.18, 200, 100, 200, 125. Let's just double check and make sure. 172.18. Yep, okay, so we are in a good address range. So that is all set. So MetalLB components are running, the speaker's going, the controller is running. So now we can actually go ahead and create our load balancer. So we already have our, if you're on page 129, we already have our Nginx running, right? So if we take a look, oops. So kube control get pods and default. There we go. So we've got our Nginx pod running. So the next thing we're going to do is create a load balancer service for this pod. So if we take a look at our services, kube control get service, you'll see that we already have an Nginx web service as a cluster IP. So this means it's only accessible from inside the cluster. So what we're going to do is we're going to create a load balancer in MetalLB running on an IP that is part of the Docker network that Kind runs on. Now, unfortunately, that means we won't be able to access it from my laptop because it's Kind. In the real world, when you deploy MetalLB, it's going to be broadcasting on IP addresses that are routable to the outside world. So what we're going to do now is create a new service. Now, the first time we created that service through the kube control expose. This time we're actually going to create the YAML for it. So why might it be important to be able to do the YAML as opposed to running kube control expose? Later in the book, at the end of the book, we're going to talk about things like GitOps, and you'd want to store this YAML inside your Git repository. So let's go back here and do nginx lb.yaml. And of course, copy and paste, strikes again. And then selector, and then type is load balancer. So looking at this real quick, obviously we're giving it a name. which ports are we forwarding to, what port are we exposing, and then the selector. So what is the label on the pod that we're going to be looking for to bind this to? And then this time, instead of having a type of cluster IP, we are going to have a type of load balancer. We could do this as well through the expose command, but we're going to shake it up a little bit. All right, so kube control create f nginx load balancer.yaml. Okay, so let's go ahead and check to see what services we have. And you'll see now that we have this new load balancer service. So this is going to the same place, except instead of going to our Nginx Ingress Controller, it's going directly to our Nginx web server. So we're bypassing the Ingress Controller. And then to test this out, we should be able to just hit this IP. Okay, so we have deployed MetalLB. We created our load balancer, and now let's give it a quick test, and it didn't work. Okay, let's take a look. So first thing, let's see if the service got announced. So when we go ahead and we run our, we create our load balancer, Scott showed us a little bit in the logs about what we should see in the log. So looking here on page 128, and yeah, so page 128. So we should see something called service announce. So let's take a look here. Kube control get pods and MetalLB system. Yeah, let's take a look at the speaker. Kube control logs and MetalLB system. Grep service announced. Nope. All right, let's try this one. Maybe it's over here. Nope. Okay, so speaker never got announced. Let's check the controller. Logs. System to grep nginx lb. All right. Okay, so the controller is allocating the IP address. That's why we saw the service. Kube control get service. We see that it did allocate the IP address, but the speaker's not announcing it, which means there's nothing listening on that IP address. So let's work backwards. So whenever you think you should be able to connect to something and you don't, first thing you should always do is check your endpoints. And typing correctly helps. Okay, so interesting. So here are two services that we created, MetalLB and Nginx Web. So we created Nginx Web at the very beginning to show working with the layer 7 ingress object versus our layer 4 load balancer, MetalLB. And you can see that we have no endpoint. So Scott explains in the chapter what an endpoint is. You will never create an endpoint manually. Endpoints will always be created for you by the controllers, by the endpoint controller. Clearly we have a configuration problem somewhere. So let's take a look at our, let's see, does that work? No. Get service wide. And let's see here, what's the difference between these services? Ah, there we go. Our selector's off. So in our original selector, we used app equals nginx web. In this one, we're using run equals nginx web, which is not mapping, or which isn't matching to our deployment. That's weird. Wonder why that is. Ah, okay, I see. So in Scott's example, he actually goes ahead and creates a new Nginx deployment using kube control run, whereas we're reusing the Nginx deployment we used earlier that used kube control create deployment. So different tools created different labels. So that's why our load balancer probably isn't working. So let's go ahead and delete our load balancer. And let's go ahead and fix it. So instead of run, we're going to use app. And kube control create f nginx lb. That was created. Okay, let's check service. Okay, so this time the selectors match. So now let's check the endpoints. And now we have the same endpoints, and let's go ahead and double check the logs for our speakers. Oh, that one doesn't have it. All right, let's see what we got here. What happens if we actually curl? Oh, that worked. Okay, awesome. Wonder why I wasn't in the speaker. Oh, helps if I knew how to spell or type. There we go, service announced. Okay, awesome. And like I said, that's not working. So we have now deployed a load balancer that is running inside of our cluster. So now obviously in an enterprise environment, you wouldn't be broadcasting your kind cluster IPs, but then again, in an enterprise environment, you wouldn't be running kind. So cool, so that gets us through creating a load balancer service. And then next up, we talk about adding multiple IP pools to MetalLB. So as a load balancer, you might be connecting in from different networks. You might want to route things differently. For instance, you might want to be able to route some things from the internet versus private networks, etc. And so our next lab here actually does, we're going to update our config map to add a different subnet. So let's go ahead and do that. Kube control, edit, config map, config, and MetalLB system. All right. To be honest, I'm a little surprised that they have not moved over to a CRD. So we're going to add a new subnet, name subnet 201. We're going to have it be layer 2 again. And we're going to set up different addresses. So we're going to do 172.18.201.100 -172.18.201.125. So this means that any load balancer that wants subnet 201 is going to listen on this address range, the 201 subnet, versus the original 200 subnet. Go ahead and save that. And then now we're going to go ahead and create a new load balancer. So this time we are going to make my life easy. And we're just going to copy this to subnet 2. Or we're just going to call this LB2. And now Now we're going to add a annotation to our service that tells MetalLB, hey, I want you to work on subnet 201. So this is very common in Kubernetes, where you will add an annotation to an object to customize it. So instead of creating a CR, which is also another common approach, use an annotation. So we'll see this more when we dive into working with Istio, where instead of annotizing the heck out of our ingress objects, we're just going to use their custom object. So it's one of two very common paths for customization. I would not be surprised if in the not too distant future, MetalLB had a custom resource that replaced the service object. But in this instance, we're going to go ahead and add an annotation. And that annotation is much larger than I'm willing to type, because I'm not going to lie, I'm kind of lazy. And so we're now saying, all right, I want MetalLB to broadcast this new load balancer on the 201 subnet. And let's go ahead and create it. Of course, I got to give it a new name. Might help. Nope. Also helps if I knew how to spell. Annotations. There we go. Third time's charm. There we go. All right. So let's take a look at our services. And you'll see we have two load balancers. One load balancer is on the 200 subnet. The other is on the 201 subnet. And let's make sure that, keep me honest, we should see our Nginx page. There we go. So we now have load balancers running on both subnets. Okay, so we have set up MetalLB. We've got running on multiple subnets, able to create load balancers. So now the next question becomes, what if you need a service that works over UDP versus TCP? Real quick refresher. UDP is the protocol that TCP is built on. TCP is reliable. UDP is not. Often DNS will run over UDP because it just performs a lot better. Back in the day, when you're still using dial-up connections, if you were watching any kind of video online, a lot of times that was UDP. To get the absolute most performance out. So if you want to be able to run a service over both TCP and UDP like DNS, the question is, how do you do it? The answer is you can't. You need to use something called shared IP. So let's go ahead and do this with our core DNS deployment. So what we're going to do is we're going to allow the outside world to access our internal DNS via either UDP or TCP using MetalLB. So first thing we're going to do is control get service and kube system. Now you'll see here that it says kubedns. And we have multiple ports open for 53, both over TCP and UDP. Don't be fooled. It's still called kubedns from a service standpoint, but it is in fact core DNS. Kube control get pods and kube system, and you'll see there's core DNS running. So the service name still says kubedns, but is in fact running core DNS. So let's clear this. And then let's go ahead and create a load balancer. So we're going to create a new service. All right, what am I going to call this? Core DNS TCP.yaml. And that's going to get all worked up, so we're going to fix that. All right, so what we're doing here is we're creating a TCP load balancer, and we're telling Core DNS, or excuse me, we're telling MetalLB using this annotation, hey, we're going to share IPs with whichever service has this label on it, or this Core DNS EXT. So then in a moment, we're going to go ahead and create another service for UDP with the exact same annotations. That's how MetalLB will know that those two services are going to run on the same IP. So kube control, create F, core DNS TCP. All right. And then we're going to do the same thing this time for UDP. And once again, copy and paste is not always my friend. So here we have the exact same annotation saying, hey, these services are going to share an IP. All right, that is, it's almost like I'm programming in Python again. All right, let's go ahead and create this, kube control, create F, UDP. All right, so we went ahead and created both, and let's take a look at kube system. Get service and kube system. And there we go. We've got two load balancers for Core DNS. Both are running against two different cluster IPs, but sharing the same external IP. One is on TCP and the other is on UDP. And let's just make sure we have our endpoints. And perfect, we have endpoints for both TCP and UDP. And then let's see, this should actually, let's give this a try. Should have dig installed? Yes, I do. Okay. So if I do dig, I don't remember what the IP address is, get service and kube system. All right, so if I do dig at this, nginx web dot default dot service should work, maybe. And it didn't. Control get service all namespaces. All right, let's try this one. Dot ingress nginx dot service dot cluster dot local. Okay, there we go. So you can see here that it is finding the right IP, and I'm guessing if I came here, 10.133.235, 10.133.235. So we're actually now able to look into our core DNS. We've shown how to fire up a layer 7 proxy using the Ingress Nginx Ingress Controller. We've set up a level 4 load balancer with MetalLB, multiple subnets. And then we also showed how to be able to split tunnel TCP and UDP to the same load balancer using DNS. So the last thing we're going to do is talk about enterprise DNS. So earlier in the chapter, we used nip.io because we didn't have a DNS server. And that can be a bit of an issue in most enterprises because you need to be able to register new names for new hosts. So the way that this is typically done is when there's a couple of different ways actually. One, there might be a manual process where you have to open a ticket or a Jira ticket or a ServiceNow ticket that says, hey, please create this DNS name with this IP address. That's really annoying and nobody likes doing it. This is an API world. We want to do it with an API. And so now if you're using something like Amazon or GKE or some automated platform that provides DNS services, you just call an API to create a DNS record. Can't do that often in an enterprise. Sometimes you can, sometimes you can't. But there are tools that will help make that more of a Kate-friendly experience. So that's the next thing we're going to handle. So first thing we're going to do is we want to set up a tool called ExternalDNS. Now, ExternalDNS uses its own etcd database. We're not going to use the same one Kubernetes uses. That would be bad. So we're going to set up our own. So the first thing we're going to do is let's go ahead and deploy etcd. Yeah, this got broken up. Oh, I know why. I forgot to add all right, Helm repo update. All right, so now let's go ahead and install etcd for DNS. Don't worry about deprecated charts. Why? Because Scott said so. All right, cool. So etcdns is done running. And let's take a look at our kube system. Kube system. And you'll see that we now have etcdns systems running. Right? Yeah. Yep. Okay, so we now have, there we go. Okay, so once the deployment is completed, and we should see an kube system. And there is our etcd cluster client. Yeah. 41 seconds old. Okay, cool. And we're going to need this IP address. So we're going to remember that for a bit later. Nope. Get the right one. Text. All right, save that for a rainy day. All right, so now we're going to add an etcd to the zone. We need to edit the config map. All right. So let's go ahead, kube control get config maps and kube system, kube control, edit config map, core DNS and kube system. All right. So he's got this after forward resolve.conf. And okay, I see what he's doing. All right. So we're going to go ahead and add an etcd for foo widgets.kate. So that's going to send all host entries for the foo widgets.kate's domain into our etcd database. Path, SkyDNS, and endpoint HTTP. What the heck? And I'm sure I'm about to cause all kinds of havoc. Is this one right? etcd cluster client? Yeah. Two, 3, 7, 9. All right. Okay. So that was set up. And then we need to deploy external DNS into the cluster. So let's go to chapter 4. And externaldns.sh. Let's take a quick look at it because we never like to just run the commands. So this is going to go ahead and pull in all of the services and rock and roll. So let's go ahead and run it. All right, so that's done running. Yeah, we don't want to deploy things manually. That's no fun. All right, so we now have, interesting. So we now have a external DNS service. So let's see here, kube control get NS. Must be in kube system. And I see core DNS. Yep. Okay, so we got external DNS running. So this is going to go ahead and so we're going to add another service. Let's go ahead and do this. All right. The Nginx dynamic YAML. And we're going to have to clean this up, obviously. Oops. And we're going to go ahead and fix this to be app and load balancer. So what this is going to do is it's going to create a new load balancer in our 200 subnet because we still have MetalLB running. And it's going to create an entry for that load balancer called nginx foo widget.kate inside our external DNS. So let's go ahead and kube control create f nginx dynamic.yaml. Okay. And then let's take a look at our services. So we've got yet another service running on 102. And let's check the pod logs. So kube control, get service, and no, get pods and kube system. And here's external DNS. So kube control logs and kube DNS or system. And let's see here. We should see. So it says add set. Okay, there we go. Add set. And there's our Nginx foo widgets Kate. All right. So we're going to want to test this. We're going to use the net shoot container. All right. So I'm now on page 144, step number 5. Bin bash. Oops. Control delete temp shell. Pod. All right, cool. So now let's do this again. All right, so let's run a NS lookup. Nginx.foo widgets. widgets dot Kates. And there we go. We have that's our address. And we can compare that. I'm just going to go ahead and delete that pod. That 172, if I do a kube get service, 172.18.200.102, here we go. 172.18.200.102. So our annotation was picked up. It was created inside of our external DNS database. So that doesn't really do us a whole heck of a lot of good. So the last thing we want to do is we're going to want to integrate with our enterprise DNS. Oh, real quick, just to make sure that we're doing everything. We check DNS, but we also want to make sure that we can hit it. So we should be able to do HTTP nginx.foowidgets.kates 8080. Yep, there it goes. So that gives us the whole round trip. So so far we have gone ahead and created this external database for DNS and a way for us to create DNS entries in it for the Kate zone. The last thing we need to do is we need to get so this actually will not be executed on our cluster, this particular lab. I'm just going to walk through what it would look like because I don't think you could actually get there from here. So essentially what you would do is, let me see, can I do this? No, I can't because it's broadcasting on a, I don't think we're broadcasting DNS, are we? Docker PS 8443.222. No, so we're not broadcasting 53, so it won't work. So the last step would be to set up a DNS forwarder. So you'd go into your enterprise DNS system and say, hey, any records requests for the Kate's domain, forward it to this server that we now have. So now that way, your users, the users of your cluster, can create DNS records without having to actually go and open a JIRA ticket. So this is a really long chapter, and we're not done yet. We still have the Kate's global load balancing. We're going to go ahead and tackle that next week. Just as a quick review, what we accomplished, we created an Nginx pod and exposed it via the Ingress Controller, the Nginx Ingress Controller, otherwise known as a Layer 7 proxy. We deployed MetalLB, configured it on a subnet, broke it, and figured out how to fix it. Configured a second subnet, and then went ahead and did split TCP and UDP so we could test DNS. And then we saw how we could create an external DNS service so that way our users can generate DNS names for our load balancer without having to open JIRA tickets. So thanks for sticking around. If you enjoyed it, I'd appreciate it if you could hit that, smash that like and subscribe button that you're going to see here in a second. And thanks for joining us, and hopefully we'll see you next week. Have a great one.